Hey everyone, Mr. Markwick here. The purpose of today's video is to run through three different methods of random sampling. So we're looking at simple random sampling, systematic and stratified sampling. Now, previous lesson we looked at the difference essentially between a census and a survey. We looked at what a sample is, but the important part of the understanding a sample was that it needed to be large enough and unbiased for us to draw reliable conclusions from a whole population. So that's why we would use random sampling. Simple random sampling is essentially just choosing members at random, where every member in that population has the same chance of being selected in the sample. It might be names in a hat, it might be a random name generator, but everyone essentially has the same chance of being selected for the sample. We won't go through an example of that because it's pretty straightforward, but I will show you a process used for systematic sampling. Systematic sampling, it says there, the sample is created by selecting members of the population at regular intervals. So for example, here an accountancy firm may wish to sample the files of 1/10 of their clients. They choose a starting file from 1 to 10. So for example, in this case, it's the third file, and then select every 10th file after that. So therefore they would select the third file, the 13th file, the 23rd file, the 33rd file, and so on. Okay. Now I'm going to go through an example and show you how that would look like in this context. So example 1 here, management of a large city store wishes to find out where the potential customers like the look of a new product. They decide to sample 5% of customers using a systematic sample. Show how this sample would be selected. So, because we're looking at 5% of customers, I'm going to first of all convert that to a fraction, just like we had in the example up here. Now, 5% per cent means per 100. So I'm going to write 5% as a fraction as 5 over 100. Okay, 5% is the same as 5 over 100. Now I'm going to simplify that. So I know how to simplify that, but if you don't, you can use your calculator. 5 over 100, and your calculator will simplify that to 1 over 20. So 5 over 100 is also 1 over 20, which means, therefore, every 20th customer will be surveyed. Okay, so for example, they might look at choosing the 5th customer to walk in the store, or the 7th customer to walk in the store, and then every 20th customer after that. So let's say they chose the 7th customer, they get surveyed about the new product, then the 27th customer that walks through the door would be surveyed, the 47th customer would be surveyed, and so on. Okay. Now, this is not part of the question, but let's just say, for example, that day, I don't know, 300 customers walk through the store. Now, how many of those customers would actually be surveyed? We're surveying 5% of them. Hopefully that's pretty easy to work out, but I'm going to show you a process to work out if the number wasn't a nice round number like 300. So basically, we're working out 5% of 300. Now, mathematically, the word of means to multiply. And if I did 5 times by 300, it's going to give me 1,500. So we can't survey 1,500 customers if only 300 customers walked into the store. So I'm going to use the fraction version in place of the percent. So convert that to a fraction. I'll use 5 over 100 just to keep it simple. But of course, you could use 1 over 20 because they're equivalent. So 5 over 100 times by 300. Again, put that on your calculator. Times by 300 will tell me that 15 customers would be surveyed in this case. Okay. Again, that wasn't part of the question. This is really the answer to the example here, but I'm just showing you how many customers would be systematically sampled if every 20th customer was surveyed using the number of 300 customers, for example. Okay. Now, the second example I'll go through today, but the third type of random sampling is stratified sampling. So this is when a population is divided into subgroups and each subgroup is represented fairly in the sample. So the example here is collecting data from students at a high school. And there are 137 students in Year 8, 152 in Year 9, 174 in Year 10, 168 students in Year 11, 121 students in Year 12. Now, because there are more students, for example, in Year 10, it would make sense that the Year 10s would have more of a say. So we should actually be surveying more Year 10s and less Year 12s because there are more Year 10s at the school. So that's the idea of the stratified sampling. So the first thing you need to do is to work out how many students in total are there? So I'm going to add all those numbers up. So 137 plus 152 Year 9s plus 174 Year 10s plus 168 Year 11s plus 121 Year 12s. Now I've already done this. The answer is 752, so I'll speed the time, type that in the calculator. There are 752 students at the school together, and we're going to, the example here says we're going to sample 50 of those students. So 50 out of 752 students are going to be surveyed, okay? Now, how many from each year level do we choose, okay, for it to be fair? So, to work it out, for the Year 8s, there will be 137 over the total number of students, which is 752, times by the sample size, which is 50. Okay, and then put that into your calculator. So 137 over 752 times by 50. And now I'm going to convert that from standard to decimal form. So press the SD button, which gives me 9.1. So I'm going to round it to 9 students. So from Year 8, 9 students will be surveyed. Then I do the same for Year 9. So how many Year 9 students will be surveyed? Again, there's 152 in total over, 152 Year 9 students in total over the total number of students at school, which is 752. Multiply that by the 50 students that we're looking to survey. Again, put that into your calculator. 152 over 752 times by 50, which is 10.1. Again, let's round that to the nearest whole number, which is 10. Again, we do the same with the Year 10s. At this point, if you want, you can speed up because I'm just going to be going through the exact same process for all the year levels. This time there's 174 Year 10s. Again, put this into my calculator and it'll give me the total. But what I might just do is change that number there to 174. This time 11.5, so I'm going to round that again to the nearest whole number. Let's round that up to 12 this time, 12 Year 10s, Year 11s, 168 over 752, that's 50. Uh, 11 students there. And Year 12s, which was the smallest group. So 121 over 752 times by 50. Again, on your calculator. would be eight students from year 8. Oh, sorry, 8 students from year 12. Now, if I add up all these numbers, 9 plus 10 plus 12 plus 11 plus 8, it should give me the total of 50, which it does. So how many students from each year level? Well, there'd be 9 year 8s, 10 year 9s, 12 year 10s, 11 year 11s, and 8 year 12s. So that's it. That's 3 different processes of random sampling. Again, the first one was just basically pulling a number out of a hat or a random name generator. The other 2, I showed you an example of the systematic sampling, where you're choosing individuals from the population at random intervals, and stratified sampling, where the population is divided into subgroups, and you're trying to represent those subgroups fairly by choosing, I guess, a proportionate amount from each of those subgroups. All right, so that's it. Thanks for watching, and hopefully that helps.